Hi everyone, welcome to my talk, Select Topics in Blockchain Security. Today we're going to talk about, well, at least some of the topics in blockchain security. There are plenty, but first let me introduce myself. So, my name is Gil. I'm the DevOps team lead for Kima Finance, a small Web3 startup, but rather innovative, if I may say so. But you know what? Forget words. Let's use icons instead. So, as you can see here, a selection of icons in some organizations and groups that I volunteer for. We have Bahat for promoting women in R&D. We have Apple Seeds for promoting people from the geographic and social periphery into tech. We have OpSchool, a school for DevOps. We have LGBT Tech, now known as LGB Work, for promoting LGBT people in tech and workplaces. We have Women Tech Makers by Google. So as you can see, I really like icons. If you have more colorful suggestions for organization for me to volunteer for, feel free to hit me up. Okay, so that was enough about me. Let's talk about blockchain security. So what we have today is API, about managing the API menagerie that comes with managing a blockchain. We have custom encrypted protocols and intrusion detection systems that's supposed to detect violations in such protocols. We have AML, anti-money laundering, stopping money laundering across various cryptocurrency networks. And last but not least, we have hardware security models, modern encryption, and best of breed key security. Lots of three-letter acronyms. Okay, so let's get started. So, APIs. When you're building a blockchain, it's building an ecosystem. You obviously want developers to build on your blockchain, to make transactions, to make products, wallets, exchanges, all of those. So it's no wonder that modern blockchains are very rich in APIs. But that's also challenging to secure because you have lots of variants of different APIs. And here's where the slight mismatch comes into life. So first, before we delve into that, API protection is split into protecting from denial of service and distributed denial of service, which attack your API availability, and they are brute force attacks. This has become somewhat of an off-the-shelf capability of stopping masses of traffic. And then you have what has only been recently turned into off-the-shelf products, semantic protections. These are products that analyze the calls to your APIs, they detect violations, and they stop all sorts of nasty things from happening. But here's the twist. When you're looking in a blockchain, you have your REST APIs. APIs as APIs do. This is the standard in all of the industries. But you also typically have gRPC, which uses protobuf for serialization. So that's a bit harder for those API products to analyze, and thus it's at times relegated to enterprise tiers. But the twist is that we're not an enterprise, and the beauty about blockchains is that it's accessible. Anybody can create a coin or a blockchain if they want to. And then you have a problem in trying to gather the defenses for this kind of an API. And then you also, when you run a blockchain, you also provide the data to your users. You have explorers, which allow people to interface with the data in your blockchain, which is usually externalized as a GraphQL interface. And that's also, like gRPC, a bit of the top of the line for API protection products. And it's relegated to enterprise tiers and offerings, and it's not as well established as protecting REST APIs. But the twist is that even if you have those three covered, blockchain networks have semantics like contract addresses, wallet addresses that can also indicate or have violations. And if you don't know what's a legal wallet address, then you won't be able to discover a violation unless you know the exact algorithm like Back32 that used to derive addresses. So, and I'm personally not aware of API products that are blockchain aware. So even if we do deploy a state-of-the-art API protection product, we still have to remain vigilant for some attacks that we know that such a product cannot intercept. But yeah, okay, we do what we can with what we do, and we're protected. So let's say that we have this one covered. So now what? Well, for better or for worse, we have more than just APIs. We have peer-to-peer protocols. Now, that's no surprise. Blockchains are decentralized, so they are peer-to-peer networks by definition, a network of validators, miners, however you want to call them, and they have custom protocols because it's not using HTTP, it's using a peer-to-peer protocol. And those protocols would be encrypted because, well, obviously, you're running cryptocurrency. Having something not encrypted would make so very little sense. So I chose two such protocols, Comet BFT and libp2p. Comet BFT is the peer-to-peer consensus protocol used by Cosmos SDK-based blockchains. And libp2p drives the interplanetary file system protocol, which is a high-scale protocol for sharing lots of content. Now, because these protocols are encrypted, we can't parse anything past the handshake. Now, when it comes to encryption of traditional protocols such as HTTPS and TLS, we would intercept and the traffic and terminate the TLS so we can analyze what is going on. Usually done by the same API protection protocol so they can look into the API. But here we cannot do that because it's not the same standard. Even if it uses TLS behind the scenes, it's not exactly the same variant, and it's also not as friendly to being intercepted and proxied because you want to know who is the peer on the other side, and if their IP looks different, then you may run into trouble. So what do we do then? We have to rely on verbose logging that something is wrong, that your protocol stack reports that it has received a suspicious packet or out of bounds, and hopefully it does that before crashing into, let's say, a shell or a buffer overflow. And the twist here that those packages are generally managed by upstream. You don't typically modify or make pull requests to the raw Comet BFT protocol. You don't mess with it. So you are reliant on their security and their approach to providing you this data so you can create a policy to protect such a custom protocol. So that's nice, that's challenging. Now let's assume that we have covered that one. So we gotta be rather protected by now, right? Right, with a slight exception. Because now we have AML coming into play. AML, for just a brief reminder, anti-money laundering. So in AML scenarios, the API isn't the problem. It's not that a bad actor is trying to mess with us by violating the APIs. It's about who they are and how they gotten their funds, probably illicit. And we don't want to let them use the API normally as well, because what they're going to do is going to be bad legally. It's not going to be violating the API or crashing our service, but it's just as bad because we don't want to do that, and it can bring us a lot of woe and regulatory trouble, and nobody wants the US government on their tail, even if you leaving the moral considerations aside. So how do we tackle this one? So first thing first, we have to keep very up-to-date data. We have to get a list of those wallets that have been flagged as being active in money laundering or that we are supposed to deny service to. But even that's not enough, because Just having up-to-date data is not enough to discover new malicious actors that would be using your service immediately as their first response. And for that, you would need behavioral analysis. You would need to look at their behavior, what they're doing with your service, and say, hey, that looks fishy. That looks like money laundering. That's something that maybe I should put a stop to. Maybe I should report them. And this is how they get listed in the first place. Someone has to find them out and has to list them. And if it can be you, then great. But the thing is that those capabilities are very complex. So I do not suggest that you try to develop them in-house. I suggest you choose a partner that you can trust and afford, to be honest, because those services tend to be very expensive at times. But if you play your cards right, then you would have a good partner that's also priced competitively, and you have that base covered. So that's great. I mean, now nobody can do malicious things with our service, right, without us responding, unless they have access to the crown jewels. So, like every cryptographic scheme, having access to the keys means everything. If I have a key to a wallet, then I can do whatever I want with the funds in that wallet. If I have a key to the validator, it means that the funds staked, the voting rights by that validators are essentially mine because I can sign transactions in the name of those validators. So protecting those keys becomes of utmost importance, and they mustn't leak, and they must be kept really, really safe. So how do we do that? So basically, there is something called hardware security modules. Those are devices that have been very meticulously developed and audited as key protection. They can be very, very expensive. They have IP that took years to develop. And then recently you have somewhat more economical options in the form of cloud HSM, which is an HSM, or rather possibly virtual one, because it's a service provided by your cloud provider. So a quick comparison, hardware security modules are best of breed. They have years of effort poured into their development, but they can be very, very expensive and sometimes outright out of reach for a small startup or a very small chain. Could be upwards to the tens or even hundreds of thousands of dollars to purchase the appropriate hardware and software. And then you have Cloud HSM, which is an economy offering that may be somewhat more viable or make economical sense, but they also require trusting your cloud partner, which is, I mean, it's common in other industries, but in the blockchain industry, which is prone to decentralization, then having such a trust might not be as, get-go or obvious as it is in other industries. Then again, we know that you can trust the clouds with, let's say, medical information. That's not so outlandish. We can do that. But there is a technology twist, you see. So, two of the ciphers used as example by cryptocurrencies are SecP 256K1 and the Edwards curve ED25519. So here's the story behind them. So SecP has two major variants, K1 and R1. And R1 has been standardized by the National Institute Standards of the United States, which is exactly the reason why Satoshi chose not to use it and use the K1 variant, because he was concerned that the NSA may have backdoored the R1 curve. And recently there's the Edwards curve, the ED25519, which was developed by an independent cryptographer by the name of Dan Bernstein, together with a team, but well, that's the name behind it. But the thing is that since those cipher suites and algorithms chosen were non-standard, it took a while for HSMs and the PKCS standard to pick up. So there are a lot of HSMs out there that do not support these standards, and there are a lot of security software stacks that do not support them either, because they are very new, and like I said, This is an industry that moves slowly. So your selection of HSMs and cloud HSMs is severely limited by the ability to support those protocols. So, to summarize, we've looked into protecting your APIs, the way that people interact with your service. We've looked into protecting the custom encrypted protocols that are used as the peer-to-peer backbone of your service. We have discussed anti-money laundering, which is legitimate service of your APIs and peer-to-peer by illegitimate parties. And we've looked into key protection in the form of HSM. And that was just a few select topics, a dip into the world of blockchain security. Thank you so much. If you have any questions, please send them to me.